Okay, this video is going to be on double and triple bonds, and I'm going to mention something about ionic bonding as well. So if a single bond means we have 2 electrons that are being shared, a double bond means that we're going to share 4 electrons, where triple bond means we're going to share 6 electrons, okay? Sometimes we don't have enough electrons for each atom to have 8 just by sharing 2, okay? And that's why a double and a triple bond will form. Now there's 2 different ways that you can do these. I'm going to show you one way. Most students like to do it this way, and then I'll show you another way where you can actually count the electrons. So an example of a double bond would be something like O2. Okay, so if I draw oxygen gas, or oxygen, with its 6 valence electrons, because it's in group 16, which means it has 6 valence, and another oxygen gas, or oxygen molecule, I keep saying gas, sorry, oxygen atom with its 6 valence electrons, we can see 2 things going on here, okay? We can see 2 electrons on each oxygen atom that doesn't have its pair, right? So these guys are paired up, these are not, okay? So the obvious thing that you could do is say these guys will be shared and these guys will be shared, and that's where your double bond is going to form, okay? So it would look something like this. Oxygen with 2 bonds, so a double bond, and then 2 lone pairs on each oxygen. You always need to double check to make sure that the number of electrons that you started with is the number of electrons that you're ending with, and that each atom has 8 electrons, okay? So I started with 2, 4, 6, 8, 10, 12 electrons, so I should end with 12. 2, 4, 6, 8, 10, 12, I do. And then I need to make sure that that each oxygen atom has 8. So what I'm going to do is I'm going to cover up this oxygen and count. 2, 4, 6, 8. That oxygen has 8. And then I'm going to cover up this oxygen and I'm going to say 2, 4, 6, 8. That oxygen has 8 as well. And then if you wanted to, you could draw 2 lines as the shared bonds. So you could say oxygen is doubly bonded to oxygen, like so. And that would be our Lewis structure for oxygen, okay? Nitrogen, let's look at this one. Nitrogen is also a diatomic, so let's write this one. So we have nitrogen with its 5 valence electrons, and this nitrogen with its 5 valence electrons. And you'll notice that each nitrogen has 3 electrons that need a partner, which means each one of those electrons will be shared on that nitrogen atom, okay? So it'll look something like this. Nitrogen sharing 3 electrons, with another nitrogen, okay? So nitrogen triply bonded to nitrogen, and I need to make sure. So I started with 10 electrons, so I should end with 10. So 2, 4, 6, 8, 10 electrons, and then I can make my structure with lines like so, okay? Let's do one more, carbon dioxide. There's another way that you can do this. You can say, okay, I have carbon who contributes 4 valence electrons, and then I have oxygen, so this is carbon, and then I have oxygen that's contributing 6 valence electrons, and I have 2 of those, so that's going to be 12, right? So 4 plus 12 is 16 electrons. So this structure should have 16 electrons. Carbon's written first, okay? So that means that carbon's going to be our central atom, okay? And then I'm going to have an oxygen probably on either side of my carbon, okay? So carbon will have its 4 valence electrons, oxygen with its 6, and this oxygen with its 6. And then you'll notice this carbon can share with this oxygen, and this carbon can share with this oxygen. So carbon's actually going to double bond to each oxygen, okay? So it'll look something like, let me move myself up here, look something like this. Carbon, double bonded to oxygen, double bonded to oxygen, okay? So go ahead and try HCN. Make sure that you're not putting hydrogen as the central atom because it just can bond once. Okay, so that's double and triple bonds. Something else that I kind of want to mention is a Lewis structure for ionic compounds. Okay, so you have to remember in an ionic compound, a cation and an anion, what we just finished talking about, is you're going to have a metal and a nonmetal. So your metals will lose their electrons where nonmetals will gain their electrons. Okay, so for instance, sodium has one electron it can lose where chlorine has one spot where it can gain an electron. So what's going to happen is sodium will throw in its electron to chlorine, and since sodium lost its electron, it'll be plus, and now that chlorine has a full outer shell, we're going to box it in and give it a -1 charge. Okay, I'm going to do 2 more examples for this. So you have MgO, so magnesium has 2 valence electrons, oxygen has 6 valence electrons. Magnesium will give its 2 electrons to oxygen, making it Mg plus 2, and oxygen, we're going to box it in because they're not sharing, they're losing and gaining, and it gained 2 electrons, so it would be -2. Okay, one more. I have 2 sodiums here, so I have Na1, oxygen with 6. So sodium will give this sodium will give 1 of its electrons, and this sodium will give 1 of its electrons. So I have 2 sodiums giving away 1 electron apiece, and then I have my oxygen with its -2 charge. Okay, so that's double, triple, and Lewis structures for ionic compounds. Thank you.